Hi everybody. This recording is for Engineering 222, Engineering Cost Analysis and Economy, on Tuesday the 16th of October 2018. Now this class number 17 is provided as a lecture video because I'm out of town today. I'm down in Clemson, South Carolina working on the FE exam. So this video is going to be a substitute for our normal in-class meeting. I will provide a PDF copy of today's in-class exercise via email so that you can follow along with the video. A couple of announcements before we get into the material. Now, first of all, homework number 10, if you look on the schedule that I gave you at the beginning of the semester, it said that assignment would be due on Thursday, October 18th, but instead I'm pushing that due date back one day to 5 o'clock on Friday, October 19th. So similar to how we worked things with homework number 9. The rationale there is just that I think there may be a handful of topics that we're going to have to discuss on Thursday, so you'll need a little extra time before you're able to submit the assignment. So make note of the revised submission deadline, 5 p.m. on Friday, October 19th. Also on your schedule is exam number 2, and that is going to be on Thursday, October 25th. In just a moment, I'll give you some more details about the format of that exam. Third, I wanted to refresh my suggestion that you get started on the project. In class on Thursday, I said that it would be a great idea over the weekend to spend some time working through that getting started part of the project, where you calculate some of the equations for certain flow rates so that you get a feel for how the equations work before you try and translate it into a spreadsheet. So please kick that off as early as you can and let me know if you've got questions. The answers are in that handout, but if something doesn't match up or you want to double check some of the finer points, stop by. Okay, today's lecture is going to be covering incremental analysis, which you know what that is because we've done incremental analysis before, but this time we're going to be combining the idea of incremental analysis together with benefit cost analysis. So B to C, remember, is when we are applying the economic analysis to projects that don't make money. So these are cost only projects. So it's kind of combining the idea of looking at the difference between alternatives in order to find the one that's best. So it's an application of decision making. Now, before we get into that, let's talk about exam 2. Exam 2 is going to be very similar to the first test with one notable exception. The main difference between the two is that on this second midterm exam, you will have some computer-based questions. And so it's imperative that you bring a laptop computer to class on the day of the exam because you're going to be using Microsoft Excel to solve at least one of the questions. Now, the restriction that I put on you when you use Excel is you're not allowed to use any of your previously created files. And so you cannot use an in-class exercise, you cannot use a homework assignment, and of course it goes without saying that you can't use the files of anybody else in the classroom during the exam. So you'll just be working from a blank workbook on that computer-based question. Now there's also going to be some concept questions that are short answer. There's going to be problem solving like there was on the first exam where you're doing things by hand. I'm going to provide the equations and the table lookup factors that you'll need, and you may bring one page front and back of notes, but you can't use that page of notes for the concept questions. And so it's not worth your time trying to define terms or, you're going to have all of the concepts committed to memory, but what you can put onto that page of notes is anything that you need for the problem solving part of it, including, if you like, column titles for how to do certain spreadsheet solutions. And so if you want to write an outline to yourself on how to do the external rate of return, I think that's a great use of your one page of notes.
So today we're talking about incremental analysis with B to C. So from last time, who can summarize or just remind us, when do we apply benefit to cost analysis? What are the circumstances that would usually apply? Go ahead.
Like a government-funded project.
Good. Yeah, so he said government-funded project, and why is it that we would use B to C analysis instead of just present worth analysis or IRR or external rate of return? Why don't we use the methods that we've always had before in such cases?
They're funded by the taxpayers.
Okay, so they're funded by the taxpayers. And they're what? Opinion matters. That's part of it. That's right. And so these projects are often nonprofit in focus, and so you can't calculate the internal rate of return, for example, on something that has a negative return. And a lot of these projects do have a negative return when they're considered only from an economic standpoint. But of course, there's more to life than money. Okay, so here is just a visual representation of comparing some alternatives. This is a flood wall, which is used to keep water out of a city. And we have a flood wall here in Huntington, a really big one. Here is a house being raised, and this is another flood mitigation measure, is actually, rather than keeping the water out of an area, you just lift everything up that has anything of value. And if you go down to coastal Florida, you'll sometimes see this, especially down in the Everglades, just houses on stilts. And in this case, I don't think it's permanently going to be on a bunch of wooden pallets like that, but it looks like they're getting ready to raise it as a flood control measure. And here are some enormous pumps. That's part of the strategy that's in place in New Orleans, is they're pumping seawater out because much of New Orleans is below sea level, and so they've got to have those pumps going 24 hours a day, 365 days a year. And during hurricanes that can knock out the power, then that really becomes a dangerous time, because when those pumps switch off, the water levels rise very quickly. So let's say that we're in a position where we need to do more than just calculate the B to C ratio. Because remember, B to C tells you a yes or a no. And what's the criteria when you calculate B to C ratio? Do you remember the threshold for saying yes versus no to a project? 1. Right. Okay, so if it's greater than 1, that means the project is acceptable, that it provides more benefit than cost. And if it's less than 1, that tells you that there are more costs than benefits. So here's the conventional benefit to cost ratio. You can see that in the numerator we've got the benefits minus the disbenefits, which are disadvantages or whatever problems and concerns arise out of the project. And then the denominator we have the sum of the costs. And a really important thing that this was emphasized in the in-class exercise that we did on Friday before the weekend, you have to move everything to a consistent time frame. So all of the costs need to go to the present or the future or an annual basis, for instance. And so the initial costs, they may not all be at year 0. You know, it may take 3 or 4 years to construct a project, but you still move that to year 0, along with the annual operating and maintenance costs, moving everything to consistent time frame. So what we're going to do to compare alternatives is we're going to order them from cheapest to most expensive, which is what we did before in incremental analysis, and we're going to calculate the differential costs, the differential benefits, and the differential disbenefits. In other words, we're going to say for the raising people's houses compared to the flood wall, how much more costly is that? What additional benefits do we get? What are the additional, like when you're trying to quantify the dollar value of the disbenefits? And then you look at, is that incremental investment justified? The criteria is going to be, again, 1. That's going to be the dividing line. So you'll do, first of all, a B to C analysis for each one by itself. You compare each alternative just by B to C analysis. But you don't know which is the best B to C ratio by the B to C. You don't know which is the best project just by the initial B to C ratio itself. So for instance, let's say this had a ratio of 1.5, this had a ratio of 2, and then this had a ratio of 1.7. That doesn't mean this one's the best. Just having the highest B to C ratio doesn't tell you which one is the best. And that's the same thing that happened when we did incremental analysis before. It's not the highest rate of return that's the best one. Remember, you keep spending money as long as you get more return than investment. And so what we want to do is chase down which alternative is going to maximize the benefits. Okay, so the criteria here, the method and the criteria for this incremental analysis is we order them from cheapest to most expensive, and then we substitute. You can notice here that the equation's a little different. The first step's just to calculate the B to C for every alternative, but then calculate the incremental between alternatives. So you're looking at the flood wall versus house lifting. What's the difference in benefit, the difference in disbenefit, and so on. And you calculate between the two, what's the return on the incremental cost, and you find out if that ratio is above 1, that means yes, the additional expense is justified, and if it's below 1, then it means no. Move on to the next alternative. And so again, we have another factor come into play that, as it did before, and that is, when you reject an alternative, then you don't use it as a comparison baseline for the next alternative. And let me show you what I mean. In the in-class exercise we're doing today, there's 4 options, A, B, C, D. And these are all flood control options. We don't know exactly what they are, but they have different initial costs, different maintenance and operational costs. They provide a variety of benefits, and there are some disbenefits associated with each. We're trying to find out which one should we do. And there's a huge range of costs. One of these projects only costs $3 million at the present. One of them costs $9.5 million. So that option D is really going to have to somehow be fantastic to be justified, because it's more than 3 times the cost of the cheapest alternative. So here in the steps A, B, and C, I sort of guide you through the process that I'd like you to apply here. But let's say, for instance, that you reject alternative B when you're doing B versus A. If you reject B, then once you're starting to compare option C, you would do project C versus project A. And so the incremental comparison is to the most previous project that was a yes. And once you've rejected a project, then the next comparison is to the second best alternative. All right? So if you've got your computer, fire up Excel. What I suggest for today is that the template's on the back of the paper, but see if you can figure out what to do on your own without looking at this. Spend the first 2 or 3 minutes just with the front side of the paper thinking about, can you figure out a way to solve this? And if you're still stuck and you just, based on what we've done before, doesn't make sense how to answer the questions, then the template is on the back. And by the way, these are a legal size paper just because that's all we had in the copy machine today. So I apologize it's so large. I guess you're a lawyer for the day. Hopefully that isn't too distasteful for anyone. Does anybody need to borrow one of these clunker computers? Hopefully we can get it to work. All right. I'm not sure if you'll be able to save because it's not activated, but give it a try. I think you'll be able to at least, very least, do the activity, but I'm not sure if it'll save when it's in activation failed mode. There's lots of ways to solve this one, but I want to point out a little trick that I'm using. So we want to find the sum of all the benefits in the present, and there's 3 different categories of benefits. So I'm embedding an equation within an equation. So where it's asking to see what's the recurring payment amount, I'm saying the sum of the flood, fire, and recreation. So I'm putting those 3 things together inside of the present value function so that I don't have to have a whole nother set on the table where I'm adding them all up. Of course, if you want to just make a column over here where you add up the sum of the annual benefits, then that's fine too. It ends up making your equation a little easier if you add those and show them separately. Either approach will work. Okay, I think most people have made some good progress, even if they haven't necessarily finished everything. Let me go over a couple of key ideas here just so that we can wrap it up. Be sure to save your file. It may come in handy later on when you're working on the homework assignment to have this available as a reference and refresh your memory what happened and why. So let's step through the interpretations here. First of all, calculating the B to C, it only tells you what's an acceptable project. It doesn't tell you which is the best project. And here's the proof of that. If you look at alternative B, it seems like it would be the best if all we were doing is choosing whatever had the highest B to C ratio. But that's not the right approach because we want to maximize benefit. We don't want to choose the one that has the best abstract ratio. We want to have, anytime you can spend $1 and get more than $1 in return, keep doing it. And so that's what these incremental comparisons do. They look at B versus A. And so the interpretation of 2.57 is that you get $2.57 of benefit for every $1 in cost on the increment. So that additional expense associated with alternative B is justified. When we look at option C, it's not because the ratio is below 1. And that is why when we reject C, that means the final comparison is D versus B, because B was the last yes alternative that hadn't yet been rejected. But we do ultimately reject B and go for D because the ratio is greater than 1. And so what that means is, even though it is the most expensive alternative by a lot, still that added cost is delivering quite a bit of added value. And so it's worth the extra money to go for that alternative. Now on the handout I asked you what is the highest interest rate that would still give you an alternative that's acceptable. And so here are the alternatives that we want to check for that. And so if we played around with the interest rate and raised them, 10%, they're all still acceptable. 12%, some of them now are dropping below 1. And so this is sort of a sensitivity analysis to see how high can interest rates go and still there's some alternative that is an acceptable project. And I think that ends up being, you know, if we were to now do goal seek, setting the criteria of this is equal to 1, I think it works out to 14.5% roughly. So let's do 0.145, and there it is. This is the last alternative that's okay if the interest rates went up like that. But they're not up that high. In the problem statement it says they're 6%, and in the case of 6%, the take-home lesson is choose alternative D.